Good afternoon. So today we're going to continue working on equation solving, but now we're going to make things a little bit more complex, if you can believe that. Before we start, we're going to think about some things you already know with fractions. So consider if I gave you something like 6 over 7 minus 2 over 7. Recall that the rules tell us to keep the denominators and subtract the numerators, so this would give us 4 over 7. I would like you to consider, though, what you actually did. So another way we could write this is that, of course, we keep the denominator, but we subtracted the numerators. So we could just write 6 minus 2, which, of course, is 4 over 7. But still, we're looking at the thinking that we're doing. So notice that we're subtracting the numerators and keeping the denominators. We, of course, don't always write it out like that, but it could be done. So consider if I gave you something like 9 minus 5 over 13. Now, of course, we all know that 9 minus 5 is 4, so we would get 4 over 13. But let's think about the way we did the first example and the fact that we could break these things apart. So we could think of this as 9 over 13 minus 5 over 13, which, of course, is 4 over 13. Just splitting these things up is another way of thinking about things. So now let's consider that this might be able to be done without just numbers. We could use variables also, something like x minus 8 over 3. To be able to deal with this, it might be more beneficial if we split this up as x over 3 minus 8 over 3. That way we can take something like this and embed it within larger questions. Such as, if I was to give you something like 3x over 5 plus x minus 1 over 3 equals 2 over 15. Notice how the middle piece of this has an expression that sort of looks like the stuff above. We have a fraction in the middle with two terms on it. So for the most part, when I look at this equation, I think of what I do and don't recognize. I do see a bunch of different fractions. I see fractions that don't divide out. So my overall strategy is going to be to multiply everything by 15. But first, I would suggest breaking this equation apart. This is what I'd like you to do. So we write down our 3x over 5, which stays the same. But this is going to become x over 3 plus. And then recognize that 1 is a minus sign, so I'm going to call it minus 1 over 3. Notice that we just broke it apart using the ideas from above. And that's equal to 2 over 15. Now I look at this thing, I see a bunch of different fractions, just like all the equations that we've done before. I notice the common denominator is 15, so I put the whole thing in parentheses and multiply by 15 over 1. You should be comfortable with doing this by now. Why don't you go ahead and pause the video and solve this. So I've distributed through the 15. Now I'm dividing out the different fractions. Combine like terms. Solve by adding 5. Divide 14 on both sides. And we get that x equals 1/2. Do be careful that 7 divided by 14 is 1/2, not 2. So again, solving this equation isn't much different than before. It's just recognizing that there's a fraction in there that has to be broken apart first. So let's try another example. If I was to give you 3x over 4 minus 2x plus 1 over 4 equals negative 1.5. Now there's something in particular we have to pay attention to with that minus sign. What we are actually going to do is distribute that minus sign to both of the things on the top of the fraction. So I'm going to keep the 3x minus 4 just like always. But now that minus sign gets distributed, so that's a negative 2x over 4. But it's also going to go to the 1. So it would be minus 1 over 4. And I might as well change this negative 1.5 into a fraction. It'd be negative 15 over 10. Again, just watch that you distributed that negative. Now that I have all the fractions separated out, I use the same strategies as before. Well, let's take a note that we need to distribute the negative. Just so we don't forget that particular piece of it. We all know how important those negatives are by now. So now I'm going to put the whole thing in parentheses and multiply by 40. Again, if you'd like to, you can pause the video, solve this on your own. So I distributed my 40. I divided out all my fractions. I combine like terms. Now I add 10 to both sides. I get 10x equals negative 4. And I divide by 10. So x is 4/10. Something's not really looking right here. Go back and check my work. Oh, that's right. Negative 600 divided by 10 is 60. So now I'm going to do negative 60 plus 10, which is negative 50. Divide that by 10, and now I get that x is negative 5. Okay. Let's try one more together. So if I do negative x plus 1 over 6 minus 5 minus 3x over 4 equals 1/3. First thing I'm going to recognize is that minus sign out front. It really is supposed to be out front of the fraction. So I would, it's in the middle, so I would distribute that. So I'm going to distribute that negative. I'm going to break apart the fractions. So I get negative x over 6 minus 1 over 6. Distribute this negative and get minus 5 over 4. And then notice that's a negative getting distributed to a minus, so it's plus 3/4 x equals 1/3. And now, just like before, I have a big equation with 5 different fractions. I look at the denominators, and 6, 4, and 3 all go into 12. Again, go ahead and pause the video, solve from here. Oh, there we go. I move up the paper. I got x equals 3, and hopefully you did too. So hopefully you see what's going on here, that we are just taking a complex fraction and breaking it apart into 2 separate fractions so that then we can deal with them just like as before. Goodbye.